Okay, good morning everyone. I'm Ruiwen from Shanghai Jiaotong University, and I'm excited here to introduce our latest work about a retrieval augmented large language model agent, which is called TRAD here. The TRAD, T-R-A-D, represents the thought retrieval and the line decision in this title, and we will introduce them in detail later in this talk. First, let me explain our motivation to conduct this research. We know that some existing work on large language models, they solve sequential decision-making tasks by using either fixed or retrieved expert trajectories as their few-shot examples for decision-making. However, such methods can suffer three major problems as we will review in this paper. First, they retrieve relevant expert trajectories with their called task metadata, including information like task instructions and where the task comes from. This can easily result in what we call plausible examples. So what are plausible examples? When the retrieved trajectory has a very similar task instruction to the current episode, but requires a totally different solution, this expert example can be very misleading toward a large language model agent to make its decision. Second, this kind of methods use complete trajectories as their exemplar. This can result in tons of tokens to serve as input for a large language model, and we know that large language model has limited input context window, so this can be a problem. Third, even if such methods can manage to feed all of this input into the large language model's context window, we know that at certain time steps inside an episode, the current state and the current decision-making process can be related to very few steps inside an expert trajectory. So using complete trajectories as an example can bring you a lot of irrelevant noise to the large language model input, and this can have an unpredictable effect on the decision-making performance of a large language model. So as discussed above, the retrieval and few-shot decision-making process should not be conducted on a trajectory level. This means we need to select a relevant step and conduct few-shot decision-making step by step differently, and we can use such stepwise selected examples for few-shot learning. So here comes the first problem. How should we choose relevant expert step as demonstrations at each step differently? As we have seen in some existing work on large language model, like I believe most of you knows about, like chain of thought and React, large language model indeed have the ability to reason about its task and its input. So just like what is done in the React paper, we use large language model to produce what is called thought before we output the actual action at each step. And this thought can contain really critical information about the current state, like the history trajectory and some future intentions about a large language model. So we believe this is indeed what we need for a stepwise demonstration retrieval for the next stage few-shot action prediction. So given that we want to use the React style thought as the query and key for our expert trajectory retrieval, we still face some problems. Like most expert trajectory we use in the large language model benchmark do not provide an explicit reasoning part or reasoning process. So we need to provide them before we use such expert trajectories for our few-shot decision making. Just before the inference time, we need to label thoughts for such expert steps in a hindsight manner. And let's look at the picture here. We give a large language model both the observation that the expert received and the ground truth action that the expert take at that step. This is to make the large language model produce a thought that exactly explains why the expert just take such kind of action, and it can be used as the key for our retrieval in the next step. So when we have such thoughts labeled in the expert trajectory memory, we can conduct retrieval during inference time. During inference time, we just conduct React-style reasoning at each step before we do actually action prediction. So we can use such React thoughts as the query to retrieve some really relevant expert steps as our few shot examples. We can just use the produced thought as query and find the k most similar thoughts inside our expert memory so that we can use them as the example. But this is not the whole story we want to tell. If we just use one step within each expert trajectory as the few shot example and the current observation, only the current observation in the current episode for decision-making input, we will not obtain a satisfactory performance for decision-making. This is because using single steps can cause you an information loss because you just drop all the other steps off. And in this case, when you produce an imperfect query, like imperfect thought, due to your limited large language model capacity, your retrieved expert step might be very irrelevant to the current state, and this loss can really harm your decision-making performance. So here comes the second problem, that how we should compensate for such loss during the single-step decision-making process. To address this issue, we just propose what we called aligned decision method. The aligned decision method consists of 3 sub-processes, and we will introduce them one by one in detail in this part. The first one is we called temporal expansion. When we retrieved like one step inside an expert trajectory, like the blue step here in the picture, we not only use this single step as a few shot example, instead we need to take like b backward steps, like here b equals 1, we take one step backwards, and we take f step forwards, like here f equals 1, we also take one step in the future. We take all these 3 steps and concat them into one step sequence, which serves as our few shot example in the next stage. And the second one is called relative order mark. Now we have this on the right, on the left hand side, we have concatenated 3 steps into one few shot example for the large language model few shot learning. And now we need to provide the large language model with more information. Like in the right, we need to provide the temporal information about these 3 steps. Just we just mark these 3 steps with something like here, the red one. We mark the retrieved blue step with step 0 here, and we mark the next step with step 1, the last step with step -1. By providing such temporal information, we can let the large language model knows the temporal relationship between such 3 consecutive steps, and also we can let large language model maybe focus more on the step 0 because it is retrieved. It is possibly the most relevant step, and the relative order mark here can just have such 2 effects. The last one is what we call history alignment. For some tasks, the optimal policy can be history dependent. What's more, the retrieve example here has been transformed into a multi-step expert sequences. So we want our policy to be history dependent as well, and we want our current input to be in a similar form, just like the retrieve step sequence. So we just insert b plus f step before the current step, also as our input to the large language model, and this is called history alignment. Now just summarize the 3 components in our aligned decision method. First, we have our thought retrieval here. We use the current thought to conduct a similarity search, and we find two relevant thought here. This up one and this down one. This one in. Now we conduct aligned decision. We first conduct temporal expansion. We take the step here. We take the retrieve step here, and we take B step before and F step afterwards, and concat them into one step sequence. And then we just mark this concatenated step with the relative order mark. We provide a relative position information. And finally, we conduct history alignment. We just insert some history steps in the current episode so that the current policy can be history dependent and current input can be more like the retrieve step sequence. And all this are fed into the large language model as the decision-making input. So that's the all for our TRAD method part. Now let me introduce our experiments. We conduct extensive experiments on LLM word and Mind2Web to mainstream benchmark for large language model agents. The first one, which is called LLM word, is a automatic householding game, and the second one, Mind2Web, is an automatic web navigation benchmark. We compare our method to the two most relevant baselines called React and Synapse. I believe most of you have known about React, which just insert a reasoning section before the action output part as in large language model agent. And I just need to introduce this Synapse baseline a little bit. It is very simple, and it's published in this year's Clear conference. It just retrieves relevant expert trajectories with the task instruction and conduct few-shot decision-making afterwards. According to its experiments, it's working really well. So let's first see the performance on these two mainstream benchmarks. We see our TRAD methods in the last line, and we can outperform both of these two baselines and their combination significantly on both of these two benchmarks. And we also conduct significance test and show that the advantage of TRAD is significant in most cases. Then we also conduct ablation studies for all three components of our aligned decision method on the Mind2Web benchmark. The result here can show that all three components are helpful on the two harder subsets of the Mind2Web benchmark, namely the two in the middle, cross-website and cross-domain. On the simplest subset called cross-task, maybe due to the fact that large language model can produce accurate thought and action itself, the history alignment and relative order mark, which provides more information to the large language model, does not work really well, but we believe all these three components are helpful towards better overall performance. We also test the effect of hyperparameter choices in TRAD. We vary the number of steps in our temporal expansion, like the forward step number and the backward step number. We also vary the number of few-shot examples used in large language model few-shot learning. We find that under different choices of hyperparameters, our TRAD method can consistently outperform the most relevant Synapse baseline. So now let's recap on our talk today. We review that trajectory-wise demonstration retrieval method and prompting method can suffer from three major problems called plausible example, context length, and irrelevant input noise. To address all these issues, we propose to use thought retrieval for a stepwise demonstration selection, which can achieve smaller granularity and obtain more relevant expert examples. Also, to supplement the information loss using single-step retrieval and demonstration, we propose the aligned decision method by providing more steps and achieve a compromise between single-step and trajectory-wise demonstration and prompting. Finally, we conduct extensive experiments on LLM word and Mind2Web benchmark, and in our paper we also show the results on real-world insurance websites. All this shows the outstanding performance and decision and decent efficiency of our TRAD method. That's all for my talk today. Thank you.